Okay, so using exponential and log functions, so we've looked at some graphs and we've done some evaluating. So now we need to talk about some equations that we will see moving forward. But we're going to start with just evaluating. I feel like we haven't done any evaluation in a long time, and I want you to get used to the buttons on the calculator. So the warm-up questions just say to use your calculator to find the answer, but show your substitution. So when I want to find f of 0, that means I'm replacing x with 0. So I'm taking out the x's, and I'm replacing them with the number 0. So going to the calculator and saying, okay, e to the 0 is 1. Okay, so you have to use the correct button on the calculator, which is the E button. Anything to the 0 is 1. Any exponent to the 0, or any base to the 0 is 1. So if you did like 7 to the 0, 9 to the 0, negative 42 to the 0, oops, except you type it in correctly, negative 42 to the 0, it's going to tell you, well, negative 1 because of the negative. So anything to the 0 power is 1. Now, h of 1. So h, remove the x, equals log base 3, remove the x, in its place, put a 1. So going to the calculator, just getting used to these buttons, you press Control and then the button with the 10 on it. We've got a base of 3, and we're plugging in 1. We get 0. So h of 1 equals 0. Number 3, we're finding g of 3. So g, remove the x, in its place, put 3's. So going to the calculator, 2 raised to the 3 minus 1, yes, I know you know that's 2, but then arrow out of the exponent. This is why we're doing this, is so that you can practice typing these things in and see all the weird stuff that can happen. And we get 7. So equals 7. G of 3 equals 7. This is why it's important to actually use the calculator so that you know what kind of weird things are going to happen to you. All right, so now evaluating functions. Same idea, and we did this yesterday too, so not really a big jump, but just repeating this process of evaluating functions when there's not just a number in the parentheses. So we're going to find j of x plus 6, which means we're going to take out these x's, and in its place we're going to replace it with x plus 6. So remove the x's, leave parentheses where you're going to put something in, and then go back and just fill it in. We know x plus 6 will replace x. And that's it. So going on to number 5. We are going to remove the x's and replace with x squared plus x. So k, remove the x, is equal to ln, remove the x. Now, everywhere we have parentheses, we just say x squared plus x, and that's all we need to do. Very straightforward. Number 6. So m of x is equal to 5e to the x. Find p of x, which is m of x cubed minus 4. So m, remove the x, 5e to the, remove the x. In their places, you're going to put x cubed minus 4. X cubed minus 4. Now write it with the proper notation at the end. It said to find p of x. P of x is equal to what you just got there, m of x cubed minus 4. All right, number 7 here, it's a little bit wackier, right? There's x's in 2 places here, so we're finding r of x is equal to q of 7x minus 1. So q of x, remove the x's, leave the parentheses, so dig the hole. Now go back and fill that in. You're taking out the x's and you're replacing with a completely different expression. It's said to find r of x, so we have to write it as r of x is equal to ln 7x minus 1 in parentheses over 7x minus 1. Okay, u of x is half log x minus x squared. Find w of x, which is u of x over 3. So remove the x's. 1/2 log. Remove the x's. Leave parentheses. Then go back and fill it in. You've taken out the x's. You're replacing all of the x's with x over 3. And it wants you to write your answer as w of x. So, directions are important. W of x is equal to 1/2 log parentheses x over 3 minus, and you could square this, so x squared over 9. Okay. Now, v of x is this polynomial. Find f, which is v of e to the x. So, we are replacing all of the x's with e to the x. So, remove them, and then go back and substitute e to the x where you removed all of the x's. Okay. It's said to call it f of x, so f of x is equal to, now if we have e to the x squared, that's a power to a power, so we multiply e to the 2x plus 2e to the x plus 2. Really not that crazy, it's just uncomfortable because you're replacing a single x with an expression that also has an x in it. So it does take some getting used to. All right, so now we have, the other day, or well, prior to this unit, we talked about baby equations. You solved on homework 6.0 baby equations, just using your knowledge of equality. So if you think about this, if we have two things that have the same base, and their exponents are different, but the two things are equal, don't we know that their exponents are equal? Yeah, so you did that whole homework on that, right? So in example 2, we have the same base, so we can write an equation for the exponents because of the properties of equality. So we get x equals 8. Now, example 3 is a little trickier. That Miss Newman, she likes to trick you. 10 to the 2x is equal to 100. Well, that's not written with a common base. Here we had a base of 2 for both of them. Here we had a base of e for both of them. So I want to rewrite 100 as 10 squared. Now they have the same base, so I know my equation is 2x is equal to 2, so x is equal to 1. Yeah? So in order to solve an exponential equation, we want to find what we call a common base, or equal base. Then use exponent properties and write an equation for the exponents. So this is actually really, really fun, to be honest. This is kind of an easy way to solve, and this is part of the reason I teach you the way I teach you to solve in Unit 5 is so that you are understanding those properties of equality as it relates to equations. So here's the thing we need to kind of write down somewhere. When you're trying to come up with a common base for numbers, you're always choosing a smaller number. So if you see 4 and 2, you're not choosing 4. If you see 8 and 4, you're not choosing 8 or 4, you're choosing 2. If you see 16 and 4, you're choosing 4. If you see 5 and 25, you're choosing 5. If you see 3 and 9, you're choosing 3. You're always choosing the smaller number. So your bases in general will be 2, 3, 5, sometimes a 7, and sometimes a 10. Go smaller. Smaller is better. Smaller is better. Okay? Do you understand what I'm saying? All right. Cool. So, I'm saying this because I am a crazy person. Yes, because I don't want to see you make a mistake. So, solve each exponential equation below for all values of x. When I see 4 and 8, I do not think 4 as a common base. I know that 2 squared is 4, and I know that 2 cubed is 8. Yes? So, just a few minutes ago, we were substituting, and we said when we make a substitution, we use parentheses. I'm substituting the number 4, but I'm just changing the way it looks. I'm saying I want to write it as 2 squared. And 8, I'm writing as 2 cubed, so that these two things are going to have the same base. Now, what do we do with the exponents? We have a power to another power, so we're going to multiply those exponents. So we have 2 raised to the 2x times 2, which is 4x, plus 2, equals base 2 of 3 times 2x would be 6x. Now that we have the same base, we can write an equation for the exponents like you did in homework 0. So 2 is equal to 2x, 1 is equal to x. Cool? All right, let's go to number 2. 16 and 32. 16, no. 4, no. 8, no. You're raising to an exponent. You're not multiplying. So 16 and 32 can both be written as 2 raised to a power. So you need to be familiar with the fact that 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. They're all with a base of 2. Use base 2. So 16 is 2 to the 4th. So I'm replacing 16. I'm just changing the way it looks. 2 to the 4th. And 32, we just saw in the calculator, is 2 to the 5th. Exponents. We have a power to a power, so we're going to multiply. So 4 times x plus 4, 2 raised to the 4x plus 16 is equal to 2 to the 10x minus 50. Now that we have the same base, I can set the exponents equal to solve the equation by properties of equality. So let's see, I'm going to bring the 4x over here, that's 6x. I'm going to add the 50 over here, that's 66. So x is equal to 11. All right. Make this one more interesting. Number 3. 27 and 9. Oh, well, 9 times 3 is 27. That's not what we care about. We care that 9 is equal to 3 squared, and that 27 is equal to 3 cubed. That's what we care about. We need a number with an exponent, not a multiplication. So we are going to replace 9, and we are going to replace 27 with base 3 representation. 9 is actually 3 squared. 27 is actually 3 cubed. So we're going to power to a power, multiply the exponents. So I've got 3 to the 6x plus 2 is equal to 3 to the 3x plus 6. Now that you have equal bases, by the properties of equality, you know the exponents are equal, and you can solve that equation. So I'm going to bring the 3x over here, subtract the 2 over here, and get x equals 4/3. All right. Oh, 4 and 8. Well, 8 is 4 times 2. Stop it. 4 is really 2 squared. 2 cubed is 8. So we know we're replacing those representations. 4 is actually 2 squared. 8 is actually 2 cubed. So power to a power, we multiply. So let's see, 2 raised to the 6x plus 2 is equal to base 2 raised to the 12x. If two things are equal and they have equal parts, we know the bases are equal, so we can set the exponents equal. 2 is equal to 6x, divide by 6. 1/3 is equal to x. All right, so now we make it trickier. Why are you an evil genius? I don't know. I just can't help myself. Oh, I forgot about this one. Let's add one to the list. I forgot about it. 6. 6 is on the list. Okay, so what are you looking at and going, oh no? You're looking at the idea that that's a fraction. And you're going, oh no. Yeah, same. So here's what I need you to do. We see the base of 6, and I know that 36 is actually 6 squared, right? So this is 1/6 squared. The problem is that 6 squared is in the bottom of a fraction. I don't want it in the bottom of the fraction. I want it in the top of the fraction. So I need to move it up. And when we move it up, that means we're going to use an exponent property that it becomes negative, right? If it's negative, we move it to the bottom. So if I'm moving it back to the top, I'm going to change its sign. Now, we have the same base, so we get to set the exponents equal. Cool. Now this one I know you feel nervous about, so I'm going to check it just to show you. If you feel nervous, go to your calculator. You can always check it. 6 to the -3 plus 1 is 1/36. Yeah, nailed it, right? So don't be nervous. You're doing a great job. Okay, so now number 6. It's a little bit more complicated, but wait for it. You see the 8 there. As much as I don't want you to use 8, I know you're going to. You know in your brain that 8 squared is equal to 64. So you're like, okay, wait, I can handle this. If I just change the 64 to 8 squared, and then I want to make it not a fraction, which means I'm going to bring the 8 to the top and make it -2. Now we have a common base, and we have an exponent being multiplied. So 8 to the x plus 2 is equal to 8 to the negative 2x. By the properties of equality, if two things are equal, then they have equal parts. So x plus 2 is equal to negative 2x. So 2 is equal to negative 3x. Negative 2/3 is equal to x. Again, the fractions make you feel scared, so go ask your calculator. So doc B. Let's see. Okay. So 8 to the negative, oh, you know what? Let's store it. I like to use k. Negative 2/3. Store for k. And I've said it 100 times, but I use k because sometimes if you use x, it messes up your spreadsheet or your graph later on, and we don't want that problem. So on the left, I get 16. Now, if I plug it on the right, on the original always, to the k, I also get 16, so it checks. I'm doing a great job. Okay, so that's those kinds of equations. You need to get the same base. Now, we're going to do some really easy log questions. I didn't give you any of these in homework 6.0 because you had never seen a log before, and I didn't want you to freak out and be sad and blah, blah, blah. So, example 1. You're going to love this. This is so easy, it's unbelievable. Look at these two things. They're equal. They both say log, which is implied base 10, right? Which means if those parts are the same, then their insides are the same. So we can write an equation, 2x plus 3 equals 5. Yeah, it's that simple. So 2x is equal to 2. X is equal to 1. I'm proud of myself. Now, here's the thing. Log equations are the third type you have to check. You have to check. We've talked about this before. You have to check for extraneous solutions. You have to check square root equations. You have to check fraction equations. And your third kind is anything with a log in it. You have to check because there could be extraneous solutions. So all you got to do is go to your calculator and actually check it. So let's see. Oh. Let me clear doc B. Log. Oh, I should use the right thing. Control log. We know it's base 10 of 2 times 1 plus 3. Is that equal to log base 10 of 5? Yep. Ding, 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 ding. Okay. So, second example. They both say natural log, which means they have a base of e, and then they just have some algebraic expressions inside their parentheses. If two things are set equal, then you can set their parts equal. So this is going to be a polynomial equation. We want to get it set equal to 0. Add the x squared over, subtract the 4x over, keep the negative 4 where it is, equal to 0. And in order to solve a polynomial equation, we factor. Since there are 4 things, I'm going to split it down the middle, and I'm going to do a GCF. So x squared, x plus 1. And then out of the second 2, we take out a negative 4, which leaves us x, and that becomes a plus 1, which means we're doing it right. So our factors are x plus 1 and x squared minus 4. And if you think you're done factoring, you are sadly mistaken. All right, so we got dots. Dots! Don't forget about dots. I should call dots something else, like dotty. Like it needs a name because it just creeps around so often. Like, oh, hey Dottie, what up? All right, so we get roots of -1, +2, and -2. So here's the thing though, what did I say a minute ago? We have to check log equations. The reason you have to check log equations is because its domain is not -infinity to infinity, right? We know the domain of a log function is smaller than -infinity to infinity. So we have to go to our calculator. So let's store some things here. I'm going to clear this out. I'm going to store negative, oh, I hate when I do that, -1 for k. And we're going to do natural log of k cubed minus 4. It says non-real calculation, which is the dead giveaway that that one doesn't work. Okay, so now we're going to try 2. Store for k. Copy this. I get a number. Okay, so now let's try the other side. Natural log of 4k minus k squared. They match, so 2 works. That one checks. Now -2. So -2, store for k. Let's see. It doesn't work because it's giving me an error. So cross that one out. The only answer is x equals 2 for that one. So this is why we have to check logarithmic equations. There can be extraneous roots, so you got to be careful here. All right, so 2 more and then it's over, right? So let's go down here. We have 2 logs, both with base 3, of 2 algebraic expressions. Since it's set equal, then we know the parts are equal. Notice I'm not crossing anything out. Don't go crossing stuff out. It's going to be quadratic, so we get the equation set equal to 0 in order to solve a quadratic. And we have to factor. So we need 2 numbers that multiply to be -30 and sum to be +3. So 30 and, oh, 13. What is my issue? Why did I get rid of that one? Let's try that. 13. Okay, so is it -3? I'm sorry, is it +3 and +10? No, because then we wouldn't get -30. So that means it has to be some form of 15 and 2. Since it's +15, it's or +13, it's -2. I cannot get my words straight. Okay, so split the middle term. 3x squared plus 15x minus 2x minus 10 is equal to 0. Split it down the center. Out of the first 2, take out a 3x. Get x plus 5. Out of the second 2, take out a -2. And we get x plus 5. So we know we're doing a good job. Our factors are x plus 5 and 3x minus 2. So we know the root for this one is -5. Then 3x is equal to +2. Divide by 3. So x is equal to 2/3. You must check. So go to the calculator, clear what you have. -5, I'm going to store it for k. Log base 3 of 3k squared. That's fine. So log base 3 of 10 minus 13k. They match, so -5 works. All right, how about 2/3? So 2/3, store for k, and I'm just going to copy that and that, and they match, so they actually both work. Good. So 2 solutions, -5 and +2/3. All right, last one. This 2 is from when I accidentally typed something earlier, right? This would have been the calculator, this extra 2 here. Oh, bless me. Okay, so now, again, ln of what's inside is equal to ln of what's inside. Since their outsides are the same, we can set their insides equal. And as soon as you see x squared, you know you have to get it set equal to 0 in order to solve. So subtract the 17x over. And because it's a binomial, there's really only 2 things you can possibly do here. Either just a GCF or dots. So looking at this, it looks like greatest common factor. I can take out 17 and an x, which gets me 2x minus 1 equals 0. So 17x is equal to 0, and 2x minus 1 is equal to 0. So x equals 0, 2x is equal to 1, so x is equal to a half. You must check these equations. So back to the calculator to see if these work. Clear what you have in there. Anytime you store, you should really clear it out. All right, so let's store 0. I like to use k. Oops. So natural log, so Control E button, of 34k squared is undefined. Yes? So it can't be 0. All right. Then we should try 1/2. Control divide, 1/2. Okay, so that we get a number. So let's try the other side. Natural log of 17, we're using k. It matches, so our answer is 1/2. Yay! All right, so homework looks like this. You're gonna evaluate with some functions. Then you have your common base questions. I will tell you number 4, step 1, 2 things with the same base. You're going to add the exponents, so that will end up being 3 to the 2x plus 1. I just want to say that first. If you were in class, I would also tell you that. And then you've got some equations to solve. On the back side, we've got some questions about transformations, about exponents, geometric series and sequences. You want to make sure you write these, do a nice job with these here. So remember that when we said diminishes by 12%, we subtracted that from 1. So 100%, if we diminish by 12, it's 88%, and we write that as 0.88. That's something I feel like is important to you. So you do a nice job here. All right? Do a nice job.